In this lesson, we're going to look at some trig applications. So these are just word problems or real-life situations based on some trig functions. So in this question, we have the number of deer, and we are given an equation for that. And just recognize that the base year, so this is starting in 2010. So question 1 says, what would the population be in 2010? So in 2010, that is time 0. So I can find the deer population at time 0 by just substituting in 0 in for t and then calculating d. So 90 times 0 is 0. I know that the cosine of 0 is 1. And so I have 750 deer initially at the year 2010. How long will it take for this to happen again? Well, in order to figure out when it would get to 750 again, I would need to know the period of the cycle. How long does it take to repeat? So 360 divided by c is the period. The period of this graph is, or c is 90. You can see that here. 360 divided by 90 is 4. So in 4 years it would repeat. So in 2014 it would be back up to 750. 3 and 4 says, when will the population reach a maximum, and what will that be, and when will it be a minimum? For that, I might want to just do my critical numbers and mapping notation. It's probably the most efficient. So my mapping notation, the c is 90, so x would be transformed by 1 over 90, and the 250 would get multiplied by the y plus the 500. So I'm going to write out my critical points for cosine. And we're going to apply these transformations to these critical points. So when x is 0, 1 over 90 times 0 is 0. 250 times 1 plus 500 is 750. When x is 90, so I'll have 90 divided by 90 is 1. Or 1 over 90 times 90 is 1. Then I've got 250 times 0 plus 500. Then I've got 180 divided by 90 is 2. Negative 250 plus 200. Then I have 270 divided by 90 is 3. And then we have back to 500. And then 360 divided by 90 is 4. And 750. So I can answer both 3 and 4 here. Here's where the maximum is. So the maximum occurs in 2010 and 2014. Maximum of 750 deer. And then I can see that the minimum occurs in after 2 years, so 2012, and has a minimum of 250 deer.